So, hi guys, today we are going to solve this problem height of binary tree after subtree removal queries. This is a hard problem, and at first, if we look at the problem, it's going to be very straightforward, and even one method is going to be very intuitive, but that is going to give us TLE, and I'm going to tell you the reason why it gave TLE. So, basically, we are given a tree, and we need to run queries over it. And in this tree, every value is unique. That's a very major point, and it's going to be a very key point of this problem as well. So here, for example, query is 4. Then I'm going to remove the entire subtree, which is starting with 4, including 4 itself. And I'll ask what is the longest height possible from root, and that is 3. Sorry, 2. So this is the edges that they are asking. The maximum edge we can have is 2, and then we can have multiple queries, and for each query we are not going to store, we are not going to remove 4. The original tree still remain intact across different queries, so we don't need to change the binary tree itself for each query. It And this problem is a good problem. This question, this example is a good one. It explains few things which we need to take care optimally. But if we look at it, 3, if we remove 3, then what's the maximum height? It's not going to affect the maximum height of the tree because it's already 1, 2, 3, right? It's 3 from the left side, left subtree, but we are affecting the right subtree. Again, for 2, if we remove it, then we are affecting the left subtree, so it's still going to be 2 because the right subtree or even the part of left subtree is going to give us 2, right? So 2 is the answer. Similarly, for 4 and 8, we can do that. The first uh, intuition that comes to our mind is if we traverse if we traverse the tree and we go to the left half till the bottom, we start bottom up, and this will return 0, all right, because the left height will be 0 for this one, and then if we check for the right height, that will also be 0. So the maximum of the left and right will be 0. Similarly, we will do that for the parent as well. We'll get 1 now because we have encountered one edge. So 1, and then we'll check this as well. And then this will be 0, this will be 1, this will also be 1, right? So let me clear stuff now. And we are at here. Let's return back, this return back, and we are at 1, 1. So this will be 1 in total. In total, as in the maximum of the left and the right possible longest path, right? Again, we'll go ahead and do the same thing until we find that we encounter a query. So we'll do this for every query, and every time we call this, we'll have a query at hand, and we'll check every time we encounter a root value, a value, a node, and when we are here, suppose we'll get the maximum from the left side as 3. We go this side, and the query is 3, suppose. We'll go here, we'll get 0, we'll return back 0 with 1 added to it, and this will be 1. But we encountered a 3, right? So instead of returning 1, we'll return 0 instead, right? Because we have encountered 3 as the query value. Hence, we are going to remove it as part of the query, and then we'll check. what's the longest path. So we'll straight away return 0 here, and we'll return 1 here because we have encountered 5, 9 as the edge, and hence 3 will be the answer. So 3 is the answer. So that's how we can do it. This will be for every query. This will be O of n, right? We are doing O of n. So for every query, so if there are n queries, so we are having O of n cross n. Suppose we have a very large. This can be an incomplete tree, right? This suppose it's very large, and O of m cross n. If you look at it, it's going to be it's going to give us TLE anyways. Constraint 10 power 5 queries length will be again okay, m is here, so either 10 power 4 or 10 power something which is lesser. So if we take worst case, then 10 power 9, that is going to give us TLE any day. But still, this approach is very intuitive, and this is the code for it. Basically, the generate height uh, is the function that is going to construct our map. This map is going to contain all the root values along with its maximum height at that point, right? So this, since we have distinct values for every node, we can have a map as well. So I initialize answer, and I go through every query, and for every query I call generate height, and I pass np and queries and root, right? And then in generate height, I'm just checking if it's equal to 0, right? If it's equal to query, then I'm returning 0 because I'm going to remove that subtree anyways for this query, right? Otherwise, I'm going to take the maximum of the left or the right, and I'm going to return the current depth. That's how this can be done. And then answer can be populated. I'm doing -1 here because I added it here instead of adding it here. I can add it here and remove it here. That will also be fine. If we try to run it, this works. But if we try to submit it, this is going to give us EM. So we see that for every query, we need something lesser because of the nature of this problem. We have to traverse every node. So O of n is going to be the time complexity definitely. So in order to solve this optimally, we have to reduce our time complexity for the queries part to O of 1 by doing some pre-computation in our first DFS itself, right? With that pre-computation, we can use that value for every query to find it in O of 1 time. How we are going to pre-compute it? So we have to pre-compute it for every possibility, right? Because queries can have any value, and I'm going to have to pre-compute for every value, right? So in the question, it's already told we cannot remove 1 because queries cannot have the value 1 or the root value. So for every other node except the root, we have to check and see and store what's the answer for if we remove this. For example, if we remove 3, then what's our answer? If we remove 3, in that case, this was giving me 2 and this was giving me 3. If we remove 3, then we are changing this back to 0, right? And for the right value, this can be anything. Right now it's 3, but if it can be anything, it has to be greater than equal to 0, right? In any ways, we are having 0 at the left. So anything is going to be greater than equal to 0. So if I remove the left subtree, I'm going to take the right subtrees maximum value. And if I'm going to remove the right subtree, then I'm going to take the left subtree maximum value. This we can do it for every node to compute the answer for every node. So that's how we are going to solve this problem. Let's look at the code, then we'll understand better. Let me just remove this part. Let me just remove this part. Let me just take the map outside. So we are going to have a map called left, which is going to store the left subtree for every node. Since we are having unique values for every node, right? We can use a map. This first part is going to store the key will be the node value, and the value, the key value pair value is going to be either the left or the right. So we are going to have two maps, L and R, and we are going to have something called H, right? Or height. So height is going to have the keys as the node values, and the answer will be, if we remove 3, or if we remove that node, if we remove the ith node, what's the answer going to be? That's our, since we have to give it in O of one operation, right? So for every query we are going to call, we are going to look up this map to get the answer. Alright. So first let's build LNR, because we have to need LNR to calculate H, right? To calculate height. So we are going to can use generate height itself, and I don't need map because I've stated it, declared it globally. I don't need query right now. I don't need this. I can just do something like this and remove this part. So instead of map, I'm going to have L. L of this root value is going to have the generate height from the left part. Okay. And similarly, I can have this for the right as well. And here for the right one, I'm going to have the R, and the root right child will be called. And here I don't need map, I don't need query, I don't need query. Alright, now I'm going to return the max of either this L or the right max, because this node is going to have the max of this and this, right? Pass back the maximum of either of the two. Okay, that's one. This is what we need. This should give me populate the left and the right map. So now we are going to compute height, right? So for that we are going to either remove the left subtree and calculate it, or the right subtree and calculate it, right? But we cannot remove the root. So we are going to have to start from here itself. We can call something like a solve function. The pre-compute will be a nice function. Pre-compute what? Pre-compute, we need the root, we need the left and the right map, left and right map, and on top of that we need actually we don't need the left and the right map since it's already global, so we don't have to pass it. but we are going to need what value I'm going to take if I remove a certain subtree, right? So say that I'm going to pass it in the function, in the recursive function itself, I'm going to pass that value, and initially I'm going to pass uh, I'm going to call this function twice here because for the left and the right subject I have to call it, and I'm going to pass the opposite values, the opposite to the one that I'm going to remove. That value I'm going to call in here. So that function will be what? This will be tree node, uh, and this will be a value called max possibility, something like that, max possible, and I'm going to pass in the current depth, because if I remove this 5 or if I remove this 7, 5 is still going to have some contribution of itself and the contribution of all the nodes in between till the root, right? So that is going to be stored in the left and the right. That's basically depth, right? So that is something we are going to need, and we are going to add it to the right value as well as we go to the recursive function. Initially, we are going to have depth here. All right. So I'm going to call pre-compute. First, I'm going to call generate height, which will generate me the height. Now I'm going to call pre-compute, which will have root left, and I'm going to have a same function here with root right, and then local things. Max possible. Right now, max possible will be what? It will be the right subtrees, whatever maximum height it is, that is here. Right? So I'm going to call right of root left or root value. Right? Yeah, that's it. And I'm going to call the depth. That will be 1. Initially it will be 1 as we are starting it here. Similarly, I'm going to have this as left because I'm removing the right subtree, and that's how we'll compute. Here we are going to return 0 if the root is null, but we are going to have to populate height, right? We are populating height of which node? This node, and we are populating it to what value? Max possible value, right? And we are calling what next? Calling the next. We are going doing a DFS. We are doing the same thing for all the other nodes. Left. Here we are going to pass what? Yeah, here I'm going to pass the root values. So I'm removing now the left subtree, right? So I'm removing the left subtree, I will pass the right value. But along with it, I also need to add something, right? Like we talked about here in the example, if I remove 5, if I remove 7, suppose 5 is still going to have its own contribution from the left side. Or suppose if I remove 6 for this exact function, if I remove the left subtree, which we are doing it here, then we should add the contribution from the right subtree, right? Because this is not getting removed. And 4 is also going to have its own depth, right? At this point, or how many number of nodes are here, it's going to have its own depth. So I'm also going to have that depth added to it. And as I go down, I'll also increase the depth here. Similarly, I'll do the same thing here. This will be L, this will be right, and that's how we return. We return what now? Since we are not actually using anything returned from pre-compute, we don't have to return anything. We can just do it as void. Right. Now that I have height populated, I can just traverse, can have answer, initialize to query size, and I'm going to traverse to all the queries, and I'm going to populate each eye with height, and I'll pass queries of height here. And that's my answer. Let's try to run this. Uh, Alright, so there was some problem right here because I'm taking the maximum current depth. For example, if I'm removing 5, I'm taking with this statement, I'm taking the depth currently, and since I'm removing the right side, I'm taking the left side as well. But I need to take the maximum possible, right? So this maximum possible should be here. It can be the answer as well. So I should do it something like this. Maximum of max possible, comma, and the same thing goes here. Now if it see if it works, let's see. It does. So this is what we need. Either we take the current max possible, which is till this point, or we take the left portion of the left maximum height plus the current depth. That's what we need for both for the left and the right side. And now if we try to submit, this works, and it's a tricky problem. If you try to dry run and look at it yourself, then that will be the best understanding that you can get. All right, thank you guys.